This is the Smart Buildings Academy podcast with Matt Scott, episode 491. Welcome to the Smart Buildings Academy podcast. Today's episode will be about ASHRAE 90.1. All the information covered in this episode can be found on our website at podcast.smartbuildingsacademy.com/491. If you've ever worked on a new construction project, tackled a major retrofit, or pursued green building certifications like LEED, you've probably heard about ASHRAE 90.1. But what exactly is it? Why does it matter? And how do you actually use it in practice? We'll be answering all of that today and more. By the end of this episode, you'll not only understand what ASHRAE 90.1 is about, but also how to leverage it to meet energy codes, save money, and deliver higher performing buildings for your clients. So let's start with the definition. ASHRAE 90.1 is the go-to standard for setting the minimum energy efficiency requirements for commercial buildings. Now, this excludes low-rise residential. This includes new buildings, renovations, additions, and even system upgrades like HVAC replacements. It covers everything from how thick your insulation needs to be, to the controls on your lighting system, to how efficient your hot water heater has to run. Now, why do we do this? Because buildings account for roughly 40% of all energy use in the United States, and a lot of that is wasted. Poorly insulated walls, oversized HVAC equipment, and lights that stay on too long, maybe even 24/7, you name it, we're wasting a lot of energy. Now, ASHRAE 90.1 is here to change that. It acts as a performance baseline. So if you meet it, you're doing okay. But if you exceed it, even better. Now, it's not just a suggestion. It's built into state and federal codes, and it's often required for certifications like LEED. Now, let's go over the scope of ASHRAE 90.1. What does it apply to, right? So this standard covers new buildings, additions to existing buildings, alterations, like maybe we have a chiller replacement or a lighting upgrade, and it includes or applies to all building systems, so your HVAC, your lighting, power distribution, envelope, lots of things, right? Now, there are a few things that it excludes, including low-rise residential buildings. These fall under different energy codes, and also industrial equipment. So things that are not designed for human comfort, like your process chillers or specialized manufacturing machinery, things that build in order to produce, not for a comfort or a building aspect. Let's break down the 7 core areas that ASHRAE 90.1 addresses, and I'll include some tips and real-world commentary along the way. So what are those areas covered? We have our building envelope. We have our HVAC equipment. We have our hot water or service water heating. We have our power, our lighting, other equipment. And then we also want to talk about the energy cost budget, or our ECB, and performance rating method. So we'll get into all of that in this podcast. So let's talk about the building envelope first. The building envelope includes the walls, the roof, the windows, the foundation, Basically, everything separating indoors from outdoors. So ASHRAE specifies things like your R values for insulation, your U factors for your windows, limits on air leakage and infiltration, and it even includes different requirements based on your climate zone. So what's acceptable in Florida is very different than what's needed in Ohio, North Dakota, or even Alaska. So here's a tip. Pay attention to fenestration. So your windows and skylights, they're often the leakiest parts of a building envelope. Now let's talk about our HVAC systems. So this is your heating, ventilating, and air conditioning systems. Now this section is massive in part to the standard. And rightfully so, right? HVAC can represent 40 to 60% of a building's energy usage. So ASHRAE 90.1 covers minimum equipment efficiencies, required controls like your economizers and variable speed drives, and also load calculations, which we've gone over on a previous podcast on here. Yes, you actually have to size your systems correctly. Now, other requirements include duct insulation. We have our zone level control and something called demand controlled ventilation, which adjusts our outdoor air based on the occupancy in the zone. Now, one mistake that I often see is ignoring your part load efficiency. So many systems are sized for peak, but run at partial load most of the time, which again is not very efficient because our machines or our equipment will cycle on and off when we really want to make sure that they are running at a consistent speed or pace and that our loads are not varied and our peaks are not too high or too low. Now let's talk about service water heating. This is the hot water used in our sinks, our showers, laundry, but not space heating. So this is for our process applications. So the standard requirements that we're calling for are high efficiency water heaters, heat recovery for flue gases, we have pipe insulation, and we have application-specific upgrades for places like hotels and hospitals. So why does this matter? In a hospital, domestic water or domestic hot water can be 15 to 20% of the total energy used in the entire building. So focusing on the energy here is very critical. Now let's talk about power or the power systems. Now this one often surprises people. ASHRAE 90.1 includes our voltage drop limitations to minimize losses in our wiring. Also includes motor efficiency standards, our transformer efficiency, and importantly, like this picture shows, our metering of our power. So the power is all building power distribution systems and certain equipment that's specified in that standard. So really we want to make sure that we're meeting all our requirements electrically. We got to check that voltage drop limitation, as I just mentioned. We need to make sure that our transformers and motors are efficient. And also, we need to make sure that we're monitoring and managing the building energy use. That's right, you need to be able to measure that energy usage. I don't think I can emphasize that enough. It sets the stage for energy dashboards and building analytics platforms. So our BAS reports, putting this out, we can see how much energy from our power. Now, lighting in ASHRAE 90.1 is a big deal. The lighting equipment and systems serving our building for lighting are needs of new buildings and new site systems. So ASHRAE 90.1 is highlighting these and making sure that these are more efficient. So some of the highlights here are that our interior and exterior lighting power limits are LPD. So that's really focusing on the maximum lighting power densities. Our controls, so that's our mandatory lighting controls, which includes occupancy sensors, daylight harvesting, and dimming or dim switches. And also the require of LEDs. So they emphasize, or ASHRAE 90.1 emphasizes adopting LEDs in your building, meaning they're more efficient, and also dimming and zoning. You don't want your rooms or your zones to be on 24/7 when it's not necessary. And you also don't need a zone or room to be as bright as it can be sometimes, and therefore a dimmer switch can be very useful from an energy saving standpoint. One of my favorite improvements is that time switch control. It ensures lights turn off after hours. Something so simple, but sadly a lot of times overlooked. Now let's go over some of the other equipment that ASHRAE touches on. Here are some of the examples. We have elevators and escalators. Those can account for quite a bit of an energy standpoint for a building. Now again, it depends on the type of building because not all buildings have elevators, right? But when they do, ASHRAE focuses on the energy usage here. We also have refrigerated display cases. Those can put off quite a bit, maybe in a college setting when we have our dormitories or our dining halls. A lot of times there are many refrigerated display cases, and honestly, a lot of times those can add up to a lot of energy usage. And then it also talks about data centers, which again are huge now, and finding ways to make or design these data centers more efficiently is very critical, and ASHRAE really focuses on the server efficiency here. So these might seem niche, but really they come up a lot. I mean, if you're designing a grocery store or maybe a call center, they might have the refrigerated display cases, or we might have a data center we're looking at. While they are not in every building like lighting, they're still very critical and not as niche as they might seem. So it promotes the adoption of efficient specialty equipment when necessary. It's not always possible to design the most efficient elevator, but when it can, there is a time and place for it, it'll be installed. Now let's talk about the compliance paths. So this section that we're going to go over introduces performance-based compliance methods that allow flexibility in how you meet energy goals. So there's different ways to get to the energy goals that you're trying to get to from ASHRAE 90.1, and they draw out the different paths, which we'll go over now. So there are 3 ways to comply with ASHRAE 90.1. We have our prescriptive path. Now think of this as a checklist. we need to make sure that we meet each individual requirement. No trade-offs allowed. So the individual requirements are for each component and system within the building that we're focused on, right? Not the process equipment, but all of the equipment that pertains to the building's operations. So your heating, your lighting, all of those items that I just went over. Now, this is good for straightforward projects with limited design flexibility. So think maybe an outlet store or a shopping mall, something very basic and something a cookie cutter, as we sometimes call it. So if every Nike store has a specific design from a lighting, HVAC standpoint, those can be very good for a prescriptive path. We kind of know what we're getting into because they're not necessarily as unique as some of the other buildings that we design. Now, our second design path is our performance path, which is in Appendix G. Now here, you build a full energy model of the building, and you can do this in multiple programs. There's Train Trace, there's Carrier HAP. There's quite a few energy modeling programs that we use, and a lot of them are very, very good. And so ASHRAE has a standard for that. So now you're allowed to trade off your energy. So think if you have better insulation, it could offset a lower efficiency chiller. So we're trying to make sure that we hit a specific goal, but the performance on the building is what we're really emphasizing. So we have all these energy simulations and modeling that can kind of help balance and adjust to make sure that our building is performed at a certain level. Now, this is most common when we're looking at specific certifications, such as our LEED certified, which I think there's gold, there's silver, there's platinum. There's different levels of LEED based on how well your energy uses or utilizes the energy within that building. Our last method is our energy cost budget method. So this is similar to the performance path, but more rigid. It focuses on ensuring the energy costs, I emphasize costs, stay below a budgeted threshold. So those guidelines are very strict. So here we have our energy credits that are required for building in accordance with Section 11.5.1. And we also have our A adjustment, which is when the project includes additions or alterations that use an adjustment factor as follows. Otherwise, use 1. Now, this is what we've talked about on today's podcast, but before I go over our summary of today's podcast, I want to cover a few other concepts. One concept is the industry impact and trends in today's design world. So ASHRAE 90.1 has been a driver of innovation. Every new version that's been recreated ratchets up the efficiency requirements. We keep getting more and more efficient as design gets better and our guidelines get stricter. So this is pushing manufacturers and designers towards better systems or more efficient systems. So ASHRAE 90.1 has influenced building codes all across the United States. A lot of our state codes look at ASHRAE 90.1. It also influences our LEED and Green Globe certifications that are very focused on energy efficiency and having more efficient equipment. And also federal building standards. ASHRAE 90.1 has quite a large reach now. And honestly, we're seeing more integration with automation platforms because energy management is no longer just about compliance. It's about performance, visibility, and we're always trying to improve, so a continuous improvement. Now, let's go over some advice before going over our summary. So some quick advice here. You got to know your climate zone. It drives many of the envelope in HVAC rules. You also need to start early in the design process when trying to focus on your energy modeling. So you need to coordinate with your MEPs, which is your mechanical, electrical, and plumbing engineers, your architects, and if you have any energy modelers that aren't your engineers, we need to coordinate with them to make sure that we understand what the goals are from an energy standpoint. We need to use modeling tools. I mentioned a few: Train Trace, Carrier HAP. We also have eQuest and Energy Plus. These are essential for the performance path that I just talked about. Another tip is to document everything. Now, we want to see compliance. Keep a clean submittal package and make sure that we can illustrate and display all of the savings from our energy in order to be LEED compliant maybe, or really just having our maintenance team look at it. And then we also have plan for the future. Think beyond ASHRAE 90.1. Look at the stretch codes and future updates. All right, let's wrap it up by going over what we've learned today. Now, the purpose of ASHRAE 90.1 is that it establishes minimum energy efficiency requirements for buildings. Now, as we mentioned, this excludes low-rise residential. The purpose of ASHRAE 90.1 and how it does that is by reducing energy use and also encouraging sustainable practices. Now, the scope that 90.1 covers applies to new construction, renovations, and systems like our HVAC, our lighting, plumbing, and again, all excludes our low-rise residential and any non-comfort related equipment. So think our process equipment. Maybe we have different mills or machines, sanders, depending on how or what the building is being used for. Maybe you have a bridge crane that doesn't really apply to the building. It's just a part of it. Now, some of the key areas that ASHRAE 90.1 covers is the building envelope. So those are our walls, windows, our roofs, our skylights, anything that can control or help control the outdoor to indoor energy being used within the building. So if we have a thicker window, we're going to prevent less heat or cooling into our building, making our building more efficient. We also have our HVAC systems. So those are our air handling units, our chillers, our VAV boxes, our air terminals, everything that's with our HVAC systems or everything that's being used in our HVAC systems. We also have our service water heating, our power systems, so our grids, our transformers, the power for any of our major equipment, all of that needs checked, and if we need to make sure that it's efficient. We have our lighting systems. So we talked about scheduling with lighting and areas that might just need to be turned off if it's after hours and no one's in there. Scheduling is very important for ASHRAE 90.1. Also dimming in lighting in certain lighting areas. We have other equipment, which we talked about earlier. Some of the other equipment could be our escalators or elevators. We also have our data centers and server rooms. So in most buildings, we do have server rooms. Those can get very hot because there's a lot of equipment in a small area, and usually they're not ventilated as well as they should be. And so they have prescriptive paths for that to focus on so that we can make sure that we cool things efficiently. And also they have humidity levels that we need to make sure they reach as well. And then it also talks about or covers energy cost budget and also the performance rating of the building and all of the equipment within the building. Now there's a couple different compliance options within ASHRAE 90.1. We have our prescriptive path, which is more like a component-based checklist approach. So again, I like to just think of a outlet store, or maybe it's a McDonald's or a restaurant that's almost identical to all of the other restaurants. It's very easy to be prescriptive if we already know the design of the building ahead of time, and they're all very similar. We can kind of come up with that plan. Now, on the other hand, we have our performance path, which is in Appendix G. This is when we need to model our entire building so that we can come up with a plan to save energy. So if we have really fancy, expensive lights that are very efficient, but our roof isn't nearly as efficient, or our value of our roof allows more air, we need to calculate all of that to make sure that we're meeting our goals for the energy usage. And then we also have an energy cost budget method, which is similar because we're still using energy simulation or modeling, but it's also based with cost limits in mind. We need to make sure that we're not going over certain cost limits. And some of the energy modeling programs that we use, as I mentioned, were eQuest, Energy Plus, Train Trace, or Carrier HAP. A lot of these can do the job, and it's really cool to see how all the systems get built out, and then you insert all of your information into there, whether it's what your base of your design for your hot water temps and how your wattage per square foot on your lighting, your R values, your U values. You can input all of this into these programs, and it'll calculate how much energy is being used based on those requirements. And also, if you can put in the cost of your energy for your area, it'll come up with some cost and help you with the energy cost budget method. So ASHRAE 90.1 can be used in several applications, as we've talked about. It's used for building codes, LEED certification, and state federal energy mandates. Thank you for listening to the Smart Buildings Academy podcast. We hope you learned a lot from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcasts or Spotify. If you're watching this on YouTube, please like, comment, and subscribe. And if you're watching this on LinkedIn, please share this with your network. As always, this will be available on our website at podcast.smartbuildingsacademy.com/491. Again, that's podcast.smartbuildingsacademy.com/491. This is Matt Scott